In this video, we're going to do some applications of solving equations. We've talked about several different kinds of equations that we can solve, from easier ones to harder ones, and all the different strategies and skills that we can use to solve different kinds of equations. Now we're going to look at sort of some real world applications when in the actual day-to-day life you might use this kind of thinking. It's very interesting. This is always a good thing to think about, that a lot of people have a hard time connecting with math, in that they don't know when they're ever going to use it. But they would be doing this kind of math constantly in their head without even realizing it. This is the kind of we're only going to look at two examples, but they are the kinds of examples that people absolutely do all day, every day, for all kinds of different things. And I think you'll see that when we go through these examples, that this is real world math that you would actually do. You wouldn't do it like this because you wouldn't be doing it on paper. You wouldn't do it in this formal math way. But discussing the formal side to it does help us be a bit more mindful, or a bit more aware of exactly what it is we're doing when we're doing this kind of math. So it is definitely useful. So let's take a look at the first example. Pizza Delight is a pizza shop. Cost of a pizza is given by the following equation. So in this question, the equation is given to us, and it says the total cost is capital C, so we can see that in the equation there. And N, which we can see in the equation there, is the number of toppings. Okay, so this makes sense. The relationship here is the more toppings you put on your pizza, the more expensive it's going to be. But there's also a base price for the pizza, right? And even if you aren't the one who's generally ordering pizza in your house, you probably have a pretty good idea that that's how pizzas work, and that's how all kinds of other things work as well, where a medium pizza costs $11, but then when you start putting toppings on it, the cost goes up. So that's what's happening here. Now, one thing we want to do, and this is something we're going to do a lot of moving forward in this course. So right now, you don't have to be an expert at this, but it is something that's going to come up over and over and over again. In fact, starting in the next unit and the unit after that, we're going to do a lot of this. So you're going to have a lot of time to really get familiar with this. This is kind of the first time that we're going to see this, but it is a really important idea in this course. And again, I think it's something that if it makes sense to you right now, it's not going to be on the test. It's not something you're going to have to do on your own right now. But if it makes sense to you and you can start thinking about it, that's going to help for later when you do have to do it on your own. What we're going to do is we're going to analyze this equation. We already know that the C is the total cost and the N is the number of toppings. So the question is, what is the 13 and what is the 2? And you may have a gut feeling or an intuition about what this means. And if anybody, normally, I would throw it out there to the class for answers. So if you want to think about that for yourself and come up with your own answer, that's great. But we will do this together. So the 13 stands for $13. Okay. And that is the cost for just the pizza, with no toppings, right? So that's that base price that, a medium or a large or whatever this is, starts at. Okay, that's what the 13 is. So what is the 2? Well, think of it this way. So it is an amount of money, and this is the number of toppings. So if the number of toppings is 1, this whole part is $2. If the number of toppings is 2, this whole part is $4, because it would be 2 times 2, right? This is that substitution that we talked about at the very beginning of this course, and I've said over and over again, it's going to keep coming up. If I want 3 toppings, then N is 3. 2 times 3 would be 6. So I'd be paying $6 for the toppings. So the $2 is the cost per topping. Okay, and this type of equation, as I said, is a very common equation. It's got a special name, it's a special type, and it's something we're going to explore a lot of throughout the rest of this course. So I'm not going to get into all of that right now, but just so you know, it is important to start thinking about. It's not the kind of thing that we can just forget because it's a one-time deal. It's definitely not. It's something we're going to spend a lot of time on. But the nice thing about it is it's very consistent. So the equations always kind of look like this. They always have some kind of base price and then some kind of cost per topping item, whatever it is, okay? Because we're not going to just talk about pizzas. But again, if you feel like you're already getting overwhelmed with the algebra side of it, looking at the numbers and the variables and the equation, just think about the real world application. Just think about how this makes sense that we have a cost of the pizza on its own plus the cost per topping. Now, again, obviously in the real world, you know, they have like deals and they have pre-made pizzas and they have all kinds of other stuff at these stores. But basically every pizza store that I've ever seen also offers you to just build your own pizza, and they have a base price for the size of the pizza and then a cost per topping. $1, $1.50, $2, sometimes 75 cents, something like that, right? So it changes store to store, but the idea is the same, and that's all this represents. And again, this is such a real world thing that we do all the time. I mean, who doesn't order pizza or all kinds of other things work this way when you're hiring a plumber, an electrician, or all kinds of things? It all follows the same kind of pattern, and who doesn't experience that, right, throughout their life? And so this is a really common kind of mathematical experience that we have. And we might do the work in our head without thinking about what we're actually doing, but this is what we're actually doing. Now let's dive into it. Use the equation to answer the following question. So we're going to notice in this example that it gives us the equation, and we're going to use the equation to solve two kinds of questions, and both questions are different, and these are the two kinds of questions that we are going to have to become familiar with. So you want to recognize the difference between question A and question B. That's part of what we're going to do. Again, this is going to be, this will be on the test a little bit, just the solving equations part of it, but we're going to explore a lot more of this later as well. So it's something that's really worth understanding, these two different kinds of equations. So let's get into it. And for each of these, I'm going to show two different strategies, okay? I'm going to show the math strategy that is sort of a math class strategy, and again, like I've said before, the reason why it is good to get more familiar with these kinds of math class strategies is they will work for harder equations. So when you go to grade 10 and go to grade 11, these are the skills that will scale up to all kinds of more difficult math. That being said, it's important to think about our intuition about how we would solve these questions as well, right? So I'm going to demonstrate for both of these, I'm going to demonstrate two different ways of doing it. And I'm going to suggest that you try doing it the more math class way. But when in doubt on a test or anything like that, if you're not sure what to do, solve it however you can. Show your thinking as best you can. Show your work as best you can. Notice it says show your work right in the question. That's really important to be aware of. That means you can't just say the total cost is $20 or whatever and think that that's a good enough solution. You do have to show some thinking, okay? I'm going to start with what I might expect people to do it their own kind of way without doing it sort of the math class way. So I'm going to start with that, but then I'm going to show you the way that it is better in the long run to get familiar with and get used to it. It is the kind of thing that you will have to be able to do in this course eventually. So you might say to yourself, a customer orders, let's read this. A customer orders a large pizza. I guess that's a cost for a large. I don't even think it says that up there. But we're talking about a large pizza here with 7 toppings. Find the total cost. And you might say, well, for 7 toppings, and they're $2 each, 2 times 7 is 14, right? And so the cost for toppings, that's a lot of money for toppings. The cost for toppings, 7 toppings is a lot. That's going to be kind of a soggy pizza, right? $14 just for the toppings. But that's not the cost of the whole pizza, because we also have to pay $13 just for the pizza itself. So you might do this, plus 13. And again, you can use your calculator to add them up and get $27. Okay, and that would be your final answer. Now, in this case, you have shown some thinking. You have shown your work. We've talked about this a little bit. It's better if you can put titles, like you can say cost for toppings plus cost for the pizza, or write some words or something like that to show an even better understanding. But if you wrote something like this, you have shown some work. This is not, I'm going to show a way that sometimes people write it that isn't as good, believe it or not. It might look a lot like this way to you, but it's not as good. 2 times 7 equals 14 plus 13 equals 27. Now, the reason why this isn't great is because, technically speaking, in a math classroom, and this is just math language, this is like if you're writing an essay in English class, and there are certain rules that you have to follow for language. This is the same in math. You have said this is equal to this, which is equal to this, and they are definitely not all equal, right? 2 times 7 was only equal to 14, and then you started adding other junk to it. And that's where you are actually writing something that's not true, and we really try to avoid that in math class. So that's not a good way of writing it. This is a little bit better because you've kind of broken it up. It would be even better if after you got 14, you called that toppings. And then on the side, you went total and did something like 14 plus 13 equals 27. That's even better if you do both calculations separately, okay? But that's the way that you probably think about this in your own intuition, okay? How would we show this, or how is it that we want to transition to be able to show this in math class, okay? So this is going to be the math class way of showing it. And again, I would strongly encourage you to try this in your work on a test. If you forget and you can't quite figure it out, do it however you can. But this is what you want to work towards. So the instructions do say use the equation. And we haven't used the equation there. We just used the concepts involved in the costs from the question. So using the equation looks like this. First of all, I write the equation. And when it says 7 toppings, that's saying n is 7. Right? And it says up in the question, n is the number of toppings. The number of toppings in this question is 7, so n is 7. And now this becomes a substitution question. Whoops, getting ahead of myself there. 2 times 7. So notice how I sub that in brackets, okay? You don't just write the 2 and the 7 beside each other. It looks like a 27, and sometimes people then think it does mean 27, and it definitely doesn't. It means 2 times 7. So you want to write it in brackets. And then this becomes a BEDMAS question. So I multiply first. And notice 13 plus 14 is the same thing we got in the other case. And that works out to $27. Okay, therefore, the total cost is, $27. Fairly expensive for a large pizza. Another way that, another thing to just point out, and this is something we talked about before, but I'll bring it up again because, sometimes hearing things a few times helps you really remember it. What if we didn't use BEDMAS properly? What if from this step, I added first 13 plus 2, and I got 15 times 7. Well, what is 15 times 7? Okay, let's find out. It's 105. So then the question, and if anybody is ever frustrated by BEDMAS and questions why we have BEDMAS, this is the answer. What is the real cost of the pizza given the cost formula or cost structure for this store? Do you think it is $105 for the pizza, or do you think it's $27 for the pizza? And clearly the store is actually going to charge you $27. So doing it this way is wrong. And that's why we have BEDMAS, so that we can communicate what we mean and everybody gets the same answer. If you went to a store expecting to pay $27 and they tried to charge you $105, you would probably say, whoa, what happened here? Something's wrong. There's no way this pizza is going to cost me $105. Okay. So again, that's another good reminder of why BEDMAS is so important. So this was a question. Question A is a question where it gives you the number of toppings, and we're going to again remind ourselves how this is different from question B. Okay. Question B says, if a customer paid $31 for their pizza, find the number of toppings that they had. Show your work. So again, it says show your work, so we can't just write down an answer. You can't just figure it out in your head. Now, you don't necessarily have to show your work exactly the way that I show it. Okay, but there are times where people write things that are wrong, and that might cause you to lose marks, or you might not show your work fully. So showing it the way that I show it is probably better. It's a little bit safer, and again, it's going to work better moving forward. That's why math teachers teach the way that they teach and teach the methods that they teach, because they know that it's going to continue to work in grade 10, 11, and 12, and college and university. But in a pinch, the most important thing is that you are showing some thinking and not just writing down an answer. So the first thing we want to recognize is this $31 is the total cost. Now, again, I'm going to start with a way that some people might think of it, and I'm going to try to write it in a way that that models the way that we would think about it. And then I'm going to show it the sort of math class way. Okay, so I am going to show it two ways. So the first thing, if $31 is the total cost, that's telling me C is $31. Okay. Now C is made up of two parts. It's made up of the $13 that's just flat for the pizza, and it's made up of the 2N that is the cost of the toppings, right? And when I add those up, in this case, that has to be $31. So I've got $31 split up into 13 and into 2N. And so what you might think of is you might say, well, what number plus 13 gives me 31? And on a calculator, that would be 31 minus 13, which gives you 18. So 2N has to be 18, right? And that way, the cost per topping and the cost for the pizza, the base cost for the pizza, adds up to the total cost. Well, if 2N is 18, I divide by 2. This goes back to solving equations like we did before. N is 18 divided by 2. N is 9. And that is what we were trying to find. The question said, determine the number of toppings. So the number of toppings is 9. And if I want to check that answer, it would be $13 for the base price of the pizza plus $2 per topping times 9 toppings, and that gives me $31. So that works. Okay? And that's the way that a lot of people are going to think about it on their own. They're going to think about how the total cost is broken up into these two parts. So that's how I've shown it here. We still had to solve a little equation, but we were just sort of thinking about it, okay? Now, how do I do it the math class way? And again, the question said use the equation. So if I'm going to follow those instructions and use the equation, what would that look like? Well, I'm going to write down the equation first again. And remember, in this case, we're given C, not N. Take a look at how this is different from the first one. In the first one, I wrote down the equation and I'm given N. I sub it in and solve with BEDMAS. In this case, I write down the equation. I'm given C. There are two variables. In A, I'm given one variable. In B, I'm given the other variable. I sub in, and I solve for n, and notice that this is a lot like the equations that we did in particular in the two-step lesson. Look at how similar this is to these kinds of equations. Okay, so again, that was why we were doing those equations at the time. Okay, so what do? We subtract 13 from both sides to move it over. 31 minus 13, if you remember, we already did that. It's 18. Then we divide by 2. And 18 divided by 2 is 9. So n equals 9, therefore 9 toppings. So if you are, and I hope you are, because that's kind of what we're supposed to do, if you're trying to connect to this math class way of doing that, and I'm kind of saying that in quotations, right? What the math class way of doing things, notice how it is very similar to the way we did it here. It's just a bit of a slicker way of writing it. But we did the same thing. I did 31 minus 13 to get 18. And then I divided 18 by 2 to get 9. I did the same thing. I've just written it in a more structured way. Okay, one more example. In New York City, the cost for a taxi ride. So again, this is another really common way that these cost structures work for taxis and those kinds of things, right? Cost for a taxi ride is $3, or maybe renting a boat, like you might rent a canoe and you have to pay $50 and then $20 an hour or something like that. Like there's all different kinds of real world situations where it follows this kind of cost structure. In New York City, the cost for a taxi ride is $3. That's the initial cost, and then $1.80 for each mile traveled. Determine an equation for this situation. And we're going to use C and N again. Now, this one's a little bit different because it didn't give us the equation. This is not something that you have to worry about right now. This will not be on the test in this unit. But again, moving forward, when we do more and more and more of this, this will be something that we do eventually. So for now, for this one lesson, for this one example, we're just going to use this as our model and recognize that our equation is going to look very similar. So we're going to have C equals the initial cost, and then the cost per. In the first example, it was topping. In the second example, it's miles. So I'm going to have C. If you used a different variable, you would not lose marks. Technically, this question is telling us to use C, but generally speaking, we're not as worried about using the same variable every single time. So the initial cost that happens one time is $3. So that's $3 plus $1.80. So I'm just going to put 1.80 times the number of miles because it's the cost for each mile. So the more miles you go, the more times you're going to pay the $1.80, right? And so there is our equation or formula for this situation, for this relationship, for this taxi company. Hopefully that makes sense. Again, you can just look back at the first one that we did and we just wrote this one out kind of the same way. And what you will find moving forward is everything comes down to that initial amount and the cost per something. That's something we're going to talk a lot about in this course. Now we got two parts left to this question, and one is giving us the number of miles and one is giving us the total cost. So again, very similar to example 2, where we're given one of the variables and we solve for the other, but we're going both directions. So I'm not going to do both methods this time. I'm going to do the math class method. C equals 3 plus 1.80 times n, where n is 14. You do have to be able to identify that 14 is the number of miles, and that's n. Again, that's described in the question. N is the number of miles. So you can go back and read through the question carefully to make sure you understand which variable is which. Okay. So then I sub in. Remember, when you sub, it has to be in brackets. BEDMAS. Notice how one of these questions, for question B, I'm using BEDMAS, which we learned in the first unit, and then for question C, I'm going to use solving equations, which we've learned in this unit. So notice how the math really builds all throughout the course, and we really are just learning skills that we need throughout the course. So 1.80 times 14, and I want that as a decimal, so I'm going to change it to a decimal, 25.2. 25.20. You don't need the zero in that case, but you know, it's money, so you might think of it as $25.20. And then add those together, and I can just do plus 3. You might be able to do that in your head. This calculator on the computer always gives me fractions, which is annoying. $28.20. Now, this has come up in the past in this class on tests and learning goals, where when people are writing a cost, they leave off the zero because the calculator doesn't show the zero, but that seems a bit weird. If we didn't have the zero there, that's a weird way of writing cost. So it should look like 20 because it's 20 cents, and that's a normal way of writing an amount of money, right? So that's something that you should always get used to and just be aware of. So therefore, 14 miles with this taxi company costs $28.20. Okay, last question. If a passenger paid $13.80, so this is less. So this should be a shorter ride, shouldn't it? That's something else that you can think about to sort of be checking your answers along the way. $13 is a fair bit less than 28, so this should be not as many as 14 miles, right? For their taxi ride, find the number of miles they traveled, show your work. So again, we're going to start with the formula. Whoops, 0.80 n, and in this case, it's giving us C, which is 1380. So I sub that in. Now you may have noticed that I've often said you need to use brackets when you sub, and I'm not using brackets. Well, it's the only thing on the left side, so I don't have to, but when in doubt, sure, it's a great idea. Why not? Okay, that's a really good habit to always be in. When you substitute, put it in brackets. In this question, as I said before, in question B, we were using BEDMAS to solve, but in this question, we have to solve it as an equation. So what am I going to do first? I'm going to subtract 3 from both sides, and I get 1080. Then I'm going to divide by 1.80 on both sides. So 1080 divided by 1.8 is 6. Therefore, this passenger went 6 miles. Now, you don't always have to go a full mile. So these questions could have decimal answers. Maybe it's 6.5 miles or 6.2 miles or 5.8 miles or something like that. It could be all kinds of answers, right? So just be aware of that we will get decimal answers in some cases for these kinds of questions. That makes sense. For pizza, does that make sense? Well, pizza stores do half toppings. You can get a topping on half a pizza, but probably not more than that. So you're not going to get 9.04 or something like that, or 9.1. And even then, I don't think in this course we're going to really worry about half toppings. So number of toppings is probably always going to be an exact answer, like 9 toppings or 4 toppings. But in the case of number of miles, it certainly could be a decimal answer, because most places that you travel are not going to be an exact number of miles. So you're going to have a decimal. Okay, so that was 2 examples involving applications of solving equations. And hopefully you can see how this example right here is very similar to the work that we were doing solving equations, but we have to do a little bit of setup first. It also ties in the idea of substitution, which we've done in the past, BEDMAS, which we've done in the past, and this new idea of thinking about these equations as representing something in the real world, which is something we're going to do a lot more of. So this is the part of the course where all the different ideas that we've talked about start to sort of overlap and tie together. and we start to get deeper into these ideas, make more sense of them, and see the value and the power of this kind of math in order to model real world situations. Okay, so always think about the equation that you're given, and whether you are given C or given N, and substituting and solving, and that should be your main focus when you start the practice for this lesson.